everybody, and welcome to the video demo of the DjWebdApp module. It's a Django app to integrate with blockchains. In this video, we're going to focus on the Ethereum tutorial. But the DjWebdApp Django app provides a few handful of features that you can use independently or use together. So there's a blockchain indexer, private key vault with Fernet encryption, blockchain writer, data normalization features thanks to Django ORM, multiple blockchain supports. So far we are supporting Tezos and Ethereum. This video is about Ethereum, and inter-blockchain contract synchronization is also possible, and we're going to be adding authentication backends for MetaMask. So let's set up the demo project, clone our repository, and install it. We're not going to be installing the binary modules because I installed it with the system package manager. Let me create a virtual env first and activate it. Now install the stuff, install the dependencies. We're also temporarily using this legacy resolver feature flag from pip install until one of our dependencies updates its own dependencies. So this is gonna be going away pretty soon, I hope. Meanwhile, this lets us go ahead and test all the features. We are going also to have to set up some local blockchains, but first let's create the demo projects database and open a shell with our environment. And because all the code that's in the documentation is also running in GitLab CI pipeline, we're not going to be using a local host, and we're going to be adding a few aliases to our etc host file. So as you can see, that one is set up fine, and we can just run docker compose up like this, and this will spawn a few blockchains and services. We have example local blockchain for Ethereum and Tezos and so on. So for this tutorial, we're going to be using fake FA12 contract, which just has a few functions just for demonstration purposes. The code is right there in the repository. It's already compiled, but were you to change it for any reason, you can recompile it with the following command. So we're going to be using the Web3p client to interact with the blockchain outside of DjWebdApp. You could use any client, it doesn't matter, but we have that one and I'm used to that one, so that's the one I'm using. So let's get a Ethereum client in our shell, which is going to have a default account because we're using G8 and a nice balance. We're extremely rich on my localhost, so let's go and load the smart contract source code. We're loading the binary that was compiled and the ABI JSON. And let's actually deploy the contract on our local G8 blockchain. We got a contract address, so we're now going to call the mint function as such. See, we're getting the mint function and sending it. Now we're going to be indexing that contract in our localhost, but before we do that, we need to set up the blockchain objects. So we are creating a local blockchain with an Ethereum provider class. And we're going to be adding a node, our own node, on that blockchain, so that we're going to be querying it. Let's now import the Ethereum transaction contract, and we're going to be creating a contract Django model with the contract address, ABI, and transaction hash that we got earlier. Let's go. Oh, I'm missing half of the code. So let me try that. Paste again. Maybe I can do it. Yeah. Great. So some variables have been already set, like the contract kind, and this contract in the database doesn't have any calls. It doesn't have the mint call yet because we haven't indexed it. But now we're going to use the blockchain indexed command, and this has indeed indexed our contract and our mint call, as you can see both there. We'll refresh the contract from the database because the indexation has updated it, and we can now see that we got a call on that contract, and that call is using the main function and the args that we have provided. So that's for the indexing feature. Let's now do some normalization. Here we have some example Django code. That's basic Django code, but let's go quickly through it. We're declaring an FA12 model with a couple of relations. We're going to focus on the Ethereum contract relation, but were you to mirror the codes from one blockchain to another, you would be using two relations like this. And we are also declaring a mint model, which has a FA12 model that we defined above. Link it to an Ethereum call, because every time a mint is indexed on the blockchain, we want a corresponding mint object in our database so that we can normalize the data. We're adding to the mint object, of course, the address and the value. And we also have a balance model, which links an FA12 to an account model and has a balance positive integer field. We are creating a balance update function which recalculates the balance for an FA12 and address. This is because we are not going to be incrementing or decrementing the balance, because in case of a reorg, some transactions are going to be removed. Those transactions, which will have the deleted state. So we really want to make sure that our balance is always fresh for every address. So that function will create or update the balance model for an FA12 and this address with the calculated total. Django provides post-save signals, which it allows to register callbacks. We're going to be registering a couple of callbacks on the post-save signal. For Ethereum transaction, we have a callback called mint normalize Ethereum. So whenever we have an Ethereum transaction that has a function of mint and that have a FA12 instance, we're going to be fetching the beneficiary from the accounts of the blockchain with the account arg that has been indexed for that transaction, and creating or updating the mint object for this FA12 for that transaction with the beneficiary and value amount, and calling the balance update function for the beneficiary to make sure his balance is up to date whenever we index a mint call. We also have another callback for when FA12 is created, because as you're going to see, we're going to be creating an FA12 for the contract that we have deployed and called mint on, and we want that any mint call that is already indexed to have a corresponding mint object created. So this is why this callback will iterate on all the calls of the Ethereum contract of that FA12 instance and call the save method to trigger all signal receivers and create the mint objects for us. So let's see how that magic works. Importing the FA12 model, creating a FA12 for the contract that we have created in the database. We see that Django reverse relation work. of course, and that we have a mint object, right, with our value and destination address. And we can also check that the balance was calculated. So pretty nice. That's how you normalize index data in DjWebdApp. Let's move on to the vault feature. First, let's import a wallet. We're going to be creating an account with our client right there and send some Ether on that new account. And let's see if we do have our balance updated. We do have our Ethers right there. Be careful. In DjWebdApp, we're always going to be using coins as a currency, but depending on the client itself, you might get other currencies. This is Waze, so be very careful with that. Let's import now this account we created with our client. So this demonstrates how to import an account inside DjWebdApp, which you wouldn't need to, but that's how you do it. You can also create a fresh wallet, in which case you would be using the account model, and this time with only a blockchain, neither an address, neither a secret key. This will automatically generate an address and a secret key for this account on that blockchain. Let's transfer some coins. First, using the DjWebdApp API, that's creating transaction, sending from the Bootstrap wallet, which we imported right there, to the new wallet, which we created right here on that blockchain, of course. And this has just created a transaction in the database. This has not done anything on the blockchain. If we want to deploy it, we call the deploy command. And we are going to be refreshing the balance of the new wallets, and we see that we get the 10 coins. Now let's deploy some smart contracts. We're gonna need the Ethereum transaction model. Let's create an Ethereum transaction with sender our Bootstrap account, state deploy, so that the state machine knows that this transaction is to deploy, with two failures before taking it out of the state machine, and with the bytecode and ABI that we loaded earlier and some arguments. This has not done anything on the blockchain, and we'll want to create another transaction which depends on this one, and that is we want to call the mint function of that contract to send 1,000 to that new wallet. This has still not done anything on the blockchain. Let's see how the state machine works. So when we call the state machine, which is called spool, it has found the one contract to deploy, and it deployed our contract. Let's refresh from the database, and we now know the blockchain level, the block level where this contract was transferred. We can wait for another block. You see, you can get your head through the provider, so we could be using this function to wait for a block. And now calling spool again has found the mint call that we created, and it deployed the mint call. And now if I'm running spool again, it will find nothing. So this is a command that you can be running continuously. We also have a manage.py command, of course. Well, that's it for today. Thanks for watching. Have a great day.